All right, gang, we're going to be working on lesson 5.5b using triangle inequalities. We're going to go through an exploration here to help us understand the topic. What I first want you to do is to copy the goal for the day. Our goal is to know if a triangle can be possible with three given numbers. I'm going to ask you to get a strip of paper, and we're going to try an experiment here to see if we can figure out how to make triangles. So let's go down here to our exploration. It says here that using a strip of paper, I would like you to rip a paper into three pieces of different lengths. What I want you to do, if you need to, pause the video, maybe get a scissors, cut off a little strip of paper off the edge of a piece of paper, and then come back and we're going to try this experiment. Now that you have a triangle, what I would like you to do is to make three pieces. And the thing is, the trick is that you must use the whole segment from end point to end point on your paper. And then after you're done, imagine that you were in class and you were to look around at the desks around you. And would all of your friends also have triangles on their paper? And would their triangles be congruent to your triangle? So I'm going to have you pause right here, get your paper, rip it into three pieces, and then we will come back and try something. All right, now that you have your triangle, or your pieces, try to make a triangle on your desk. I would like you to lay them out end to end and see if you can make a triangle. Down below here, I actually have three strips of paper, and I ripped them all differently. My first strip of paper, there's my original, and then I ripped it into two different sets of pieces. The first triangle, I have these, or the first piece of paper, I have these three strips, and I'm going to turn them to see if I can make a triangle. So if I turn one like this and maybe like this, and then try to spin this one around, will it fit? And maybe I have to turn this one a little bit more and turn this one a little bit more, and eventually I'm going to get something that's pretty close to a triangle. Would you consider that a triangle? And yeah, I have a triangle. Does your triangle look like my triangle? Did your triangle even work? If you looked around the room, would everybody in class have a triangle that looks exactly like this one? And the answer is maybe they wouldn't. Here I have ripped another piece of paper a little bit differently, and here are my three pieces. And the question is, can I make a triangle with those? So if I put these guys on the ends of this long segment here, definitely don't have a triangle yet. Let me turn them a little bit more and turn this one a little bit more. And do I have a triangle yet? And in fact, if I turn them even more, is it even possible to make a triangle? And it turns out that the two short strips, if you could imagine, would fall and hit the ground before they would meet each other at the top. I don't get a triangle at all. It turns out that there are certain rules that must be in place in order for three numbers to actually make a triangle. For example, if my original segment was 20 inches, centimeters, feet long, and I cut it up so that I had these numbers, maybe an 8 and a 7 and a 5, that might make a triangle. But if I cut it up so that I had a 12 and a 6 and a 2, that would not make a triangle. 12 plus 6 plus 2 does equal 20, but I have this gap in the middle, and so my two short ones are not long enough. On this side over here, if I add 8 plus 7 plus 5, that also equals, 20 over there. That equals 20. But those three numbers do make a triangle, and so we have to figure out what is the rule that we want to write to figure out if three numbers make a triangle. So let's write our conclusion for this idea of three numbers making a triangle. And what our textbook says is that the sum, and remember sum is just addition, the sum of the two shortest sides must be greater than the longest side. If you look at our numbers from above, the two smallest sides, 5 plus 7, compared to 8, would be 12, and are the two smaller sides more than the largest side? And the answer is yes. If you look at our second example, 6 plus 2 compared to 12, is the sum of the two smaller sides more than the larger side? And the answer is no. That's why that does not make a triangle. What I'd like to do now is pause and have you jump ahead to page 2. We have one more exploration to do before we finish up our notes. All right, for this exploration, the problem that we have is we are not quite sure what are the two smallest sides. So if you look at this problem, it says set up three inequalities to help find the range of the third side of the triangle. It's hard to know if that x right there is more or less than 14 and 18. So we need to set up a set of three problems, three inequalities greater than less than problems to figure out what range of values we can have for our third side. So we set up three problems. The first one is going to be with the x and the 18, assuming that they are the two smallest sides. And I know that that has to be greater than the third side. And then we set up with 14 and 18 and assume that that is greater than x. And then we set up the third one, the x plus 14, and hope that that is greater than 18. We need to figure out each of these equations, which one will give us the solution. So in the first one, when we solve that, minus 18, we get x greater than negative 4. Then when we solve the second one, and we just have to add those two numbers together, we get 32 greater than x. And I'm going to flip that guy around so that we have x on the left. And on the last one, to solve this one, we subtract 14 from both sides, and we get x greater than 4. Each of those is the solution to the problem, but when we look at them, one of them doesn't make sense. If you look at this first one, it talks about the third side being greater than negative 4. My question is, can this side be negative? And the answer is no. So these two give us the solution to the problem. All in all, that feels like a lot of work, but what I want you to notice is these two numbers that we have right here, and how do those two numbers relate to those two numbers. If you notice, 32 is the sum of 18 and 14. And 4 is the difference of 18 and 14. So really, to find the range of the third side, all you need to do is add and subtract the two numbers that are given to you. So what I want you to write on your paper is the unknown side is always going to be between the difference of the two sides and the sum of the two sides. When you are given two numbers, all you need to do is minus them and add them and put your third side between them. We will jump into our practice problems and practice that. If you understand it, go into your homework, and if not, check out the next video.